This video we're going to look at how we can solve simultaneous equations graphically. Now, before we can do this, we need to understand our straight line. So go back and look over your straight line graphs notes from M3 or the wee bit we've done in the previous video even on drawing straight lines. Okay, here in example 7, it says you can see you've got your line y is equal to x plus 4 drawn, minus x plus 4 drawn. You've also got your line y is equal to x minus 2. So this point here, where they intercept, will be the solution of the two equations, the simultaneous equations. Y is equal to minus x plus 4 and y is equal to x minus 2. Because at this point, you're on the green line and you're on the red line. Or you could say that differently. You could say you're simultaneously on the red line and on the green line. So that's why the point, the coordinate, is a solution of this equation and this equation. So it says use the graphs above to solve a simultaneous equation. And the first one is y is equal to x minus 2, y is equal to minus x plus 4. Just pull that down so we can see it. So the solution is just going to be the coordinates of that point. So that point is 3, 1. So your answer is x is equal to 3, comma, y is equal to 1. And that is it done. Part 2 says y is equal to solve y is equal to 2x plus 2 and y is equal to minus x minus 4. So we haven't got that in our left diagram, it's in the right diagram. So here you've got y is equal to 2x plus 2 and y is equal to x minus 4. And the solution where they intercept then is that point would be minus 2, minus 2. So we'll just pull that into our notes then over here. So we'll just put that as minus 2, minus 2, which means x is equal to minus 2, y is equal to minus 2, and that's it done. This example, part B, says solve graphically the simultaneous equations y is equal to 3 plus 2x and y is equal to x plus 5. And it said to draw from x equals 0 to x equals 6. So that's nice when they've given that for us. We can actually use that as a table of values in some way, shape or form. So first thing I'm going to do is mark on x equals 0, x equals 1, x equals 2, x equals 3, x equals 4, x equals 5, and x equals 6. Okay, so we've done that. I'm now going to draw the two lines. So my first line is y is equal to, well, it's 3 plus 2x. I'm going to write that as 2x plus 3. And I'm going to put in a couple of values. So I'm going to put in x equals 0. See what the corresponding y value is. So when x equals 0, y equals 3. When x equals 1, y is equal to 2 times 1 plus 3 is going to be 5. Okay, if I put in the next one, if I put in 2, 2 times 2 is 4, plus 3 would be 7, but that would take us off our graph. So 1, 2, 3, 4, 5, 6, that would take us off the graph. So we've got those 2 points, that's enough for us to get started plotting this one. So if we plot this at x equals 0, y was equal to 3, at x is equal to 1, y is equal to 5, and we'll just draw those, we'll link those up now with a straight line using your ruler. And again, my straight line is going to be a bit wobbly, just the way the device I'm using here, but that's as best as we can. So that was y is equal to, and we'll label it their way, 3 plus 2x. Okay, can we change in the question, change that to y is equal to x plus 4? It just works out a wee bit nicer on the graph if we draw in y equals x plus 4. So the other graph we're going to draw is y is equal to x plus 4. We're going to use your x values of 0. See what the corresponding y value is. When x equals 0, y equals 4. When x equals 1, 1 plus 4 is 5. When x equals 2, we really could put in x equals 2 as well. X equals 2, 2 plus 4 is 6. So there's 3 points we've got. So when x equals 0, y is equal to 4. When x equals 1, y is equal to 5. So we've already got that one done. And when x equals 2, y is equal to 6. So we're going to link up those 3 points. And then it's very obvious now what the answer is. We've sort of given the game away here. And there we are. So that was your line. Y is equal to, that was x plus 4. And you can see where they intercept, and I'll just do the circle out there in green, they intercept then at 1, 5. So your solution, we'll just say that, sorry, I'll put it back to blue, and we'll say the intercept, that is our point 1, 5. So your answer will just say, your answer is just going to be, answer is x is equal to 1, y is equal to 5. So you can see in both those lines, they both go through the point 1, 5. So that's why they're up. So point is the solution, because 1, 5 is simultaneously on y is equal to 3 plus 2x, and 1, 5 is also on at the same time. It is equal to y is equal to x plus 4. This example says the equations for the sides of a triangle are 3y plus x equals 9, 3y is equal to minus 8x minus 12, and y is equal to 2x minus 4. Find the vertices of the triangle and use 1 square for 1 unit. First thing we're going to do is do our table of values out. So we're going to do these out and see what happens. So we'll start with our 3y plus x is equal to 9. So for 3y plus x equals 9, what I would do, I've maybe set this out a wee bit differently than I have in the notes. I would say put x equal to 0. So if you put x equal to 0, you have 3y equals 9, which means y is equal to 9 divided by 3, which is 3, which gives you the point 0, 3. Also, I would say put y equal to 0. So that means 3 times 0 is 0. That means your x is just equal to, x is equal to 9. So that gives you the point 9, 0. So we can plot that point. We'll come back to that in a minute. Next point we have to do, or next line we have to do, I should say, is 3y is equal to minus 8x minus 12. Okay, that is a bit of an awkward sort of line. I'm going to rearrange that. I'm going to bring the 3 across, and I would have minus 8x minus 12 all divided by 3. And I'm going to do a table of values just for this one, I think would be the easiest way. So I'm going to have x values, and I'll put in a couple of x values and see what my corresponding y values are. So when x equals 0, you're going to have just minus 8 times 0 is just 0. Then minus 12 divided by 3 would be minus 4. And I'll put in a multiple of 3. I'll put in 3 or minus 3. I'll put in 3 first and see what happens. So minus 8 times 3 is going to be minus 24. Minus another 12 is minus 36. Divided by 3 is going to give you 12. Probably going to be off our scale, so I'll do minus 3. You can do any number at all. I'm just trying to pick numbers which might be nice. So if I put in minus 3, I'll have minus 8 times minus 3, which is positive 24. Minus 12 is 12. And then divided by 3 is going to give you 4. Okay, so I'm just going to show how I got that one. That was minus 8 times minus 3, minus 12, all divided by 3. You can do that on your calculator, and you would get 4. Okay, when I'm plotting this, just so you know, show what I would actually be doing, I said the middle one's going to be off, so I'll be plotting 0, minus 4, and I'll be plotting minus 3, 4. Okay, last of our lines to draw, we had y is equal to 2x minus 4, and again, I'll just do a table of values. Only I need a couple of points. When x equals 0, y is equal to minus 4. When x equals, we'll do 1. When x equals 1, 2 times 1 is 2, and then minus 4 is going to be minus 2. We'll do another one, put in 2. X equals 2, 2 times 2 is 4, minus 4 is 0. Okay, zooming down to our graph, we've got your x-axis, you've got your y-axis, and then we're just going to label this. So it said use 1 square for 1 unit. So that's going to be 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, and 6. And then the minus ones. So you can see I put the markings on first, and then I do my numbers. Minus 1, minus 2, minus 3, minus 4, minus 5, and minus 6. And then on the vertical axis again, -1, -2, -3, -4, -5, and -6. Okay, we're going to go back and plot our points. So, a bit of zooming about here. For the first line, we had 0, 3. So 0, 3 was here. And we also had 9, 0, which is not going to be any good for us. Okay, so this is a good thing that's happened. You can see 9, 0 would be way off the scale. It would be off here somewhere. So it's not going to be any good for our diagram. So we're going to have to go back to this one. So this happens. Good to see. So we've used one which is not going to work for us. We're going to try a different one as well. So we'll say when maybe x is equal to 3, that means you're going to have 3y plus 3 is equal to 9, which means 3y is equal to 9 minus 3, which is 6, which means y is equal to 6 divided by 3, which is 2. So we're going to plot those points. So that gives you the answer of the point 3, 2. So we're going to plot those points. So we're going to plot we'll just circle the ones we're going to plot. 0, 3, and 3, 2. So 0, 3, you can see we've already plotted. 3, 2, so 3, 2 is going to be here. And then we can link those up with our straight line and see what we get. So that was your line. That was your line 3y plus x is equal to 9. Okay, we're going to go back and draw the next one. So the middle one, you can see we're plotting point 0 minus 4. So 0 minus 4 is here. The other point is minus 3, 4. So minus 3, 4 is here. And we'll link those two up. Use our ruler again. So using a ruler again, link those up and see what we get. Okay, so that was your line y is equal to, 3y is equal to minus 8x minus 12. And then your last one, we had a couple of points doing this one. It was 0 minus 4. So 0 minus 4. Then 1, you were at minus 2. And then at 2, you were at 0. And we can link those up. I'll zoom in on that to make life a wee bit easier for myself. So linking these 3 points up and see what we get. And there we are. Okay, so we'll just label that one as well. That was your line y is equal to 2x minus 4. And then the answer, the vertices, find the vertices of the triangle. So the vertices are so we had point over here, which is minus 3, 4. So minus 3, 4. We had this point here, which is minus 4, 0. 0 minus 4. And this last point, which is 3, 2.